In combining functions part 1, we're going to talk about performing operations on functions. The four major operations we perform on anything are addition, subtraction, multiplication, and division. So this may be new notation to you, but what it says is add function f of x with g of x. In other words, add x minus 3 and x squared. When you add functions, it's like adding polynomials from Algebra 1. You're just going to combine like terms, if there are any like terms to combine. This particular problem has no like terms. Subtracting functions. The only thing you have to be careful with when you're subtracting functions is I always put them in parentheses. The reason is because the second function may have many terms. This particular one has one. So the final answer is actually just x minus 3 minus x squared, and there are no like terms to combine. Multiplying functions. We're going to multiply x minus 3 and x squared. This is going to end up being distribution. One of the things that may not be as familiar to you is distributing something that's behind the function rather than in front of. You're probably used to there being something over to the left of the parentheses. That's okay, it works the same way. We're going to get x cubed minus 3x squared. And then the last operation is division. We're not going to do much with it other than we're going to write f of x on top and g of x on the bottom, and that's all we're going to do. The polynomials can get a little more difficult. So if f of x is 2x plus 1, and g of x is 3x squared plus 8x minus 1, when we add f of x plus g of x, we actually have some like terms to combine this time. 2x and 8x are like terms. I get 10x. And minus 1 and minus 1 gives me minus 2. And there's nothing to combine with the x squared. We don't always write it this way. Mostly, you probably learned it by writing the polynomial in descending order of powers of x. So traditionally, we would write this as 3x squared plus 10x minus 2. But I don't actually care what order you put the polynomial in. For subtraction, again, this is the case where you have to be careful. You're subtracting the entirety of 2x minus 1 minus the entirety of 3x squared plus 8x minus 1. When you learn to subtract polynomials in Algebra 1, your teacher probably told you to distribute the negative 1. Your teacher may have also done it this way. Say, change this to a plus, and then change all the signs of everything in the second parentheses. Those both really mean the exact same thing. I'm going to do distributing. So 2x minus 1, nothing happens to. But the second polynomial becomes negative 3x squared, negative 8x, and positive 1. Now we go into our like terms again. 2x and negative 8x is negative 6x. Negative 1 and 1 is 0. And then negative 3x squared has nothing to combine with it. Multiplication is going to take a little bit more work. 2x minus 1 times 3x squared plus 8x minus 1. So one of the methods you may have learned to multiply polynomials together was by distributing the first term to everything in the second polynomial. So you would get 6x cubed plus 16x minus 2x. Sorry, this should be 16x squared. And then distribute the second term. You would get negative 3x squared, negative 8x, positive 1. And then you can combine your like terms. These are like terms. These are like terms. So the final answer would be 6x cubed plus 13x squared minus 10x plus 1. But another way you may have learned to do polynomial multiplication was the box method. I particularly like the box method because It's a way of finding the area of a bunch of smaller boxes, and then you just add the areas together. So one of the polynomials has two terms. So along the side here, I'm going to put the the 2x and the -1. The other polynomial has three terms, so there are three columns, and there are two rows. So I'm going to put 3x squared here, 8x here, -1 here. To find the area of a box, you do length times width. Length times width. So 2x times 3x squared is going to be 6x cubed. The next box is going to be 2x times 8x, 16x squared. The next box is going to be 2x times -1, -2x. Then in the next row, it's going to be -1 times 3x squared, which is -3x squared. -1 times 8x is -8x. -1 times -1 is +1. And you end up finding the like terms right here on the diagonals, and there's your 6x cubed plus 13x squared minus 10x plus 1. Whichever method works the best for you is the method you should use. Last but not least, f of x over g of x. So now I've already forgotten what f of x was. It was 2x minus 1 goes on top, and 3x squared plus 8x minus 1 goes in the denominator. And right now, that's all we can do with it. What if my functions aren't polynomials? What if they're square root functions? This gets a little bit trickier, and we're going to have to do a little bit of a review of radicals. So before I perform the operations on this, here's a little review of radicals. In order to add or subtract two radicals, they have to have the same items under the square root sign. In other words, they work like terms. So the square root of 2 plus the square root of 3 is kind of the same thing as saying x plus y. Well, x and y aren't like terms, you can't combine them. So this is as simplified as it gets. You can add them if what's under the radical is the same. So the square root of 2 plus the square root of 2 is kind of like saying x plus x. And since x plus x is 2x, the square root of 2 plus the square root of 2 is 2 the square root of 2. It's not the square root of 4. Because they're like terms, you're just going to add the coefficients. All right, so now we're ready to go back. F of x plus g of x is going to be the square root of 4 minus x squared plus the square root of 1 plus x. And you can't do anything to that because what's underneath the square root signs is not the same. For subtraction, same thing. The same rules apply. Unless you have the same thing under the radical, you can't combine anything. So that's all I can do. Now, multiplication is a different story. So let's talk about multiplying radicals for a second. The square root of 2 times the square root of 3 is actually going to be the square root of 6. If you multiply two radicals together, as long as they're the same type of radicals, they both have to be square roots, or they both have to be cube roots, then you can just multiply together the numbers under the radical. This, however, because one of the numbers is under a radical and the other isn't, you can't multiply 2 and 3 together. This would just be 2 square root of 3. All right, now that we've reviewed that, let's go back and do multiplication. F of x times g of x is going to be the square root of 4 minus x squared times the square root of 1 plus x. I can multiply these together. And in order to do that, I'm going to distribute. So I'm going to get 4 plus 4x minus x squared minus x cubed. And none of them are like terms, so they just stay under the radical, and that's the final answer. For dividing two radicals, there's not a lot you can do. You can write it like this, or you can write it like this. If the numerator and denominator are both under a radical, then you can write them under one radical. There is a way to get rid of the radical in the denominator. We will review that at another time. Now let's talk about fractions, everybody's other favorite F word. When you add or subtract two fractions, they have to have a common denominator. And in this particular example, they don't. So what we do is we look for something called the least common denominator. A lot of times with fractions, the least common denominator is going to be the product of the two denominators. So if I need the common denominator to be x plus 4, then the first fraction needs an x plus 4, and I tack that onto both the numerator and the denominator. And the second fraction needs an x. And so I give an x to the numerator and the denominator. You'll notice now that the denominators are the same. When you add two fractions that do have a common denominator, you just put the denominator in the bottom, but the numerator you're actually going to combine like terms. You're going to add the numerators together. So this is 2x plus 8, and you're going to add that to 4x. So the numerator is going to be 6x plus 8, and the denominator is just x plus 4. And that would be the answer. Now, if I do this again for subtraction, I already know what the common denominator is. So 2 over x, 4 over x, what did I say it was, plus 4? So 2x plus 4 over x plus 4, minus 4x over x plus 4. And I'm going to subtract the numerator. So the numerator is going to be 2x plus 8 minus 4x. And then the denominator is just x plus 4. So the final answer would be negative 2x plus 8 over x plus 4. In order to multiply the two fractions, when you multiply fractions together, you just multiply the numerators and you multiply the denominators. So when I multiply the numerators, I get 8. When I multiply the denominators, I get, you can either write it as x plus 4, or you can write it as 8 over x squared plus 4x. I've now run out of space. I can't move my screen up anymore. So last but not least, f of x over g of x. When you divide two fractions, division of fractions is really multiplication, but it's multiplication by the reciprocal of the denominator. So when I multiply these together, I'm going to get 2x plus 8 in the numerator, and I'm going to get 4x in the denominator. There actually is a little bit more simplification that can be done because everything shares a common factor of 2, so I can divide it out. But I'm going to leave it there for now. So combining functions, part 1, is about adding, subtracting, multiplying, and dividing functions. General polynomials, like the ones we did in Algebra 1, are relatively easy because you've had a lot of practice with those. What you haven't had as much practice with is combining other functions like rational functions, those are your fractions, or square root functions, or if I had given you absolute value functions. And that's just something we're going to practice over the next couple of days.